Hello guys, today we're going to finish 4.2 logarithmic functions. The logarithmic function with base 10 is called the common logarithm function. The function f of x equal to log base 10 of x is usually expressed as f of x equal to log x. So we can use the calculator to evaluate common logarithms. Here we have a couple examples. So on your calculator here we have a log. Okay, so let's look at the first one, log 1000. So it's really straightforward. And then we're going to hit enter. And then we'll also have log 5/2. And then we'll also have log 5. And then divide by log 2. Okay, and then hit enter. So let me go ahead and just write down the answer really quickly. Okay, alright, let's go ahead and move on to the next question. Example 2, modeling height of children. The percentage of adult height attained by a boy who is x years old can be modeled by f of x equal to 29 plus 48.8 log of f x plus 1, where x represents the boy's age and f of x represents the percentage of his adult height. Approximately, what percentage of his adult height has a boy attained at age 8? This question seems very complicated. However, if you look at this, they give you a model function, then they ask you the height for a boy at age 8. Okay, in this case, all you have to do is we're just going to plug in this 8 for your x. And then you simplify it, that will be 29 plus 48.8 log 9. So the rest of the stuff, you're going to plug this inside your calculator, and then finally you're going to get answer. So around 76%. So we say 76% of his adult height has a boy attained at age 8. Okay, this is your final answer. So here we have properties of common logarithms. Last video we talked about the general properties, and here we have common logarithms. The only difference, a common logarithm have a base 10. So they just give you a comparison. Example 3, evaluating without using calculator. So part A, log 100. In this case, we can think this as log base 10 of 100, right? So in the past we set this to x, then we know that we can just think this, right? Draw a snail, and then we're going to say 10 to the what power give you 100, which in this case is x equal to 2, right? So we say the log 100 is 2. Alright, let's look at B. Log 10 to the power 7.1. So if you look right here, we have a property 1, 2, 3, 4. Okay, so if you match them, this is your property 3, right? So then we're gonna look, so what is your x in this case? Your x is just gonna be 7.1. Maybe I'll use this. This is your x. So this is your x right here. If you match it, so I'm just gonna give you 7.1. And then let's look at part C. 10 to the log 21. That, if you look at this whole thing, is just going to be the property 4. So whatever is your x, we're just going to match it. So that is your 21. That is your final answer. Example 4, begin by graphing g of x equal to log x. Then use the transformation to obtain the h of x equal to log x minus 5. Remember, if there's no base, that means your base is a 10, right? That's your common log. So this is very similar to what we have learned from last session. We have to graph the common log first. So we know the base is a 10, which means we have to graph the exponential function first. We're going to plug in a couple points. You can take your time to do this. And then we said once we have this, we're going to switch the order pair. So we're going to have our g of x just going to be our log x. Then we're just going to switch our x, y. Once we have this, we can go ahead and graph this. If you want to graph f of x, that's fine. But again, all they're asking is begin by graphing g of x, log x We don't have to graph the exponential function. 1, 0, so you're going to have something like this. Obviously, this graph is going to be really hard because we're going to have like 102, so we can't really graph it in this case. Alright, so we're going to have, once you know this is a g of x, so hopefully you remembered, we have the log x minus 5 just going to be log x minus c form, which means this is moved to the right side 5 unit. So which means here we're going to have h of x, which is equal to log x minus 5. Okay? So once you have your g of x, we'll move this to 5 units to the right. So you got to remember, often the question asks you to graph your vertical asymptote as well. Okay, if this question asks you the domain and range, that means the domain, we're just going to start with from 5 to the positive infinity. And now our range, we're just going to go up, down. That would be negative infinity to positive infinity. And then also your vertical asymptote in this case just going to be x equal to 5. Okay? So we've done a similar question before, so that's why we did pretty quick. Alright, let's go. Alright, natural logarithms. The logarithmic function with base e is called the natural logarithm function. F of x equal to log base e of x is expressed as f of x equal to natural log x. So here we have a joke. Why mathematicians love parks? The answer is because they love natural logs. Let's go ahead and look at the example 3. Finding domain of natural logarithmic functions. We have part A, f of x equal to natural log 3 minus x. So for this type of question, so all you have to do is just set this apart, 3 minus x greater than 0. So then you can solve this. So we can solve this. I'll move the negative x. That will be greater than negative 3. So we divide the negative 1 both sides. So we have to change the sign. That means it's x less than 3. So I can write this. So what I'm going to do is I'm go ahead just going to write the chart. So I'm going to say this is 3. So less than 3. I'm saying is this side. So you can recall all the way to the left side is negative infinity. So I always write domain from a small number to bigger number. So we're going to have domain from negative infinity to 3. Okay? Parenthesis because we cannot include 3. So that is my answer. Now let's look at part B. So again, we said anytime we have something like this, all we have to do is we set that to x minus 3 squared greater than 0. So when you look at this, no matter what happens, when we square something, we always get something positive, right? But the thing is, because our domain can only be greater than 0, cannot be 0, you have to think this, okay? What if I'm going to put x equals 3? If I'm going to put x equals 3, right? And then what happens here? You're going to have 0 squared, and then you're going to 0, right? So, but if you look at the question right here, x has to be greater than 0, cannot be 0. So that means we have to exclude, everything else works, we have to exclude 3. Okay, so we have to exclude 3, that means everything else works. In our domain, in this case, from the left to right, we're going to have negative infinity to 3. We have to exclude the 3, and then this side is a positive infinity. So that is our answer. Okay? This part B a little bit tricky, so make sure you actually understand it. Okay? Here we have a properties of natural logarithms. So they also have a comparison to your general properties. So we're going to focus on this piece right here. So let's go ahead and look. Example 4, part A. Natural log e to the second power. If you look at this, 1, 2, 3, hopefully you realize we're using the third one. Okay? So your x in this case is our 2. So which means we're going to get 2. Another way to think about this, you can just think anytime you have natural log and you have an e, they kind of just cancel out. So let's look at part B. Natural log e to the 7x squared. So again, this case, we can think is natural log and e, they cancel out. So what's left over is 7x squared. So part C, e to the natural log 2, where our property 4 not match this, right? So which our answer is 2. But again, if you can just think, alright, e, and then we see natural log, I can just thinking about, oh, they cancel out. So I'm going to write it down. This is property 4. And then the last one, D, natural log 1 over e. Alright, if I look at this property, none of them satisfy this condition. I can rewrite the natural log 1 over e as natural log e to the negative 1 power. Okay? The reason why I can do this, let me write it on the right side. We know 1 over a to the n power just equal to a to the negative n power. So I can think this 1 over e just going to be the invisible 1 part right there. So I rewrite this as e, and then my n in this case is 1, and then here we're going to have a negative 1. So we have natural log e to negative 1 power. Now we see we have natural log, we have e. We said we can just think them as they cancel out. That is our solutions. Next question is a application question. You can pause your video and read this question. Alright, this question is very long. So the main thing you need to look, they give you a function, models the temperature increase f of x. And then we're talking about another thing is important. What is our x? We said x is x minutes. When you have application questions, you really want to save your time. You want to read very smart way. You look at the main function, and then you look what's the x, and then you look what they're asking you. The question is after 15 minutes. Okay, so I want you to find. So use the function to find the temperature increase to the nearest degree after 15 minutes. Okay, so after 50 minutes, right there. We had a function f of x equal to 13.4 natural log x minus 11.6. Then they ask after 15 minutes, then all I have to do is plug this 50 inside your function. So I'm just going to plug it in. That will be 13.4 natural log x become 50, the minus 11.6. So natural log of 50, you inside your calculator, you have this, alright, ln t. So you can just plug it in. So use your calculator, you're going to find this answer around 41. They want you to say how well does the function model the actual increase shown in the graph. You look at this graph at 50, right here actually. Okay, so you look at the number, the output, this number is 41, which is exactly the same. Let me use this color, 41. So they are exactly the same. So which means this model is really accurate, right? Because it's exactly the match. Okay, so that is how to do this question. Alright guys, that is our 4.2. Thank you for watching the video. I'll see you guys next time.